morning, everyone. My name is Jorge, and I'm a PhD student at NYU. And today I'm going to present our paper, HistoryTracker, Minimizing Human Interactions in Baseball Game Annotation. So bear with me, even if you don't care about sports, I hope you're going to get something out of this presentation. So, well, this paper is about capturing tracking data for sports, but why do you need this? Tracking data is revolutionizing sports analytics. So nowadays, every team sport and major league uses sports data and tracking data to capture knowledge about the sport, and based on that, create new strategies, develop skills, and prevent injuries in players. Now, how do we compute tracking data? Traditionally, either people use automated methods or manual methods. In the automated methods, companies put lots of cameras and radars around the playing field, and those radars are going to capture the position of player and ball through time at a very high frame rate. So on the positive side, these automated methods create a high volume of data. However, there is like a catch. So the data is not perfect. If you look at the chart on the right, you're going to see that half of the pop-up balls and 20% of the ground balls in baseball games are missed by the MLB tracking system. So there has to be another way to do this. And there is. So people have been using manual tracking as well to capture this data. And basically, manual tracking systems use specialized software plus trained human annotators to create data that's reliable and available to everyone. So as an example, Opta is one of the biggest companies that does manual annotation for sports. And they have a huge coverage. So they cover 14 of the major team sports nowadays. Just to see the size of how much it's used, they have annotated the FIFA World Cup games. So the question is, manual tracking is widely used, but can we make it better? And the answer is yes. So we propose HistoryTracker, which is a system that takes advantage of historical tracking data to improve baseball manual annotation. And how much better are we talking about? Our system is 26% faster and 30% more accurate than the baseline manual annotation. What's the idea? We warm start the annotator, so we give an initial approximation of the play to the worker using historical tracking data. And traditionally, this is a very simple idea. Basically, you have a lot of plays that you have annotated before or you have tracking data for, and then you can use these plays that you previously captured to warm start the annotation so that the user doesn't have to annotate everything from scratch. This is how our system works. So this is a picture of a view of the system, and it's intentionally blurred out so that you don't read anything. But these are the three components of our system. There's the fast play retrieval, the event-based tuning, and the refinement on demand. And we're going to cover each one of them in more detail now. Basically, we have a database of 3 years of automated tracking data that we can use to warm start the hand annotation. And this is roughly 80,000 plays in our database. This is how the plays look like. On the left, we have the spatial-temporal trajectory for ball and players. And on the right, we have the associated events for this game. So you have in gray the events associated with player actions, such as ball was pitched, ball was hit, and ball was caught. And in green, you have the events associated with player movement, such as player reached a base or player ran. We map from those events to an index that can be easily queried and retrieved in the database. So essentially, each one of those events is associated with a bit that can be either 0 or 1, whether this event happened or not. So in display, you have that the ball type is a grounder, the player running is also happening, and the first baseman also is also running. So this is how it works. Instead of asking the users to annotate these bits one by one, we map these game events to questions that are more intuitive for the user to answer. So questions such as which players ran, or who are stealing bases, and what's the better end base. So basically, the user has to answer those questions just by clicking in those checkboxes, and then we retrieve a trajectory that approximates the play that he's seeing, like so. So let's say that the user annotated this questionnaire on the left. We map this questionnaire to an index, and then we retrieve the trajectory that matches this index as best as possible using Gjoka similarity. Another thing that we allow is we allow the user to weight those questions so that they can give more importance to certain events in the game. For example, here we're weighting the who ran action as with more weight, and in this way we give more importance to the players that ran in the field. Finally, now that we have a trajectory for our approximation, we have to align this trajectory with the video that the user is seeing. And this is how we do it. Basically, the video and trajectory might not be aligned initially. So if you look at the video on the top and the trajectory on the bottom, you're going to see that the trajectory starts moving before the video, like so. So the ball is moving, but the play didn't start yet. So we have to somehow align those two in order to enable the game annotation. And this is what we do. First of all, we automatically align the events based on the hit sound. Then we let the users align the video and the trajectory events by dragging and dropping those events on the field. And finally, we requery the database so that the events match them in the temporal aspect. So this is how it looks like. The user just has to click, drag, and drop the video frame across the screen. So ball was caught. Now he's annotating the ball was released event. And finally, the ball was caught again. After each time that the user drags and drops this game, it's going to require the database and retrieve a trajectory that approximates the game in a better way. So you're going to see that the player and ball now are aligned with the video. Like so. Finally, this is the part where the manual annotation really happens. So some elements of the retrieve trajectory might not represent the video correctly. Let's say, for example, that in this case, the first baseman does not match the video. So we have to let the user fix this trajectory somehow. And the way we do this is very simple. We just let the user select the element that he wants to annotate, and then we clear this trajectory and let the user manually annotate it from scratch. But notice that all the other players are already positioned in the field. So this is going to make the process much faster because the user doesn't have to annotate every single player. He just has to annotate the players that he thinks needs to be fixed. So intuitively, this is going to be much faster than the baseline manual annotation. Our system is then comprised of just these 3 steps that are going to make the annotation much faster and more reliable. But how do we evaluate this? The evaluation is made by comparing the manual tracking from scratch with our system, HistoryTracker, and it was done using 10 plays and 8 users. So each play is annotated 8 times, 4 with the baseline annotation and 4 with HistoryTracker. And just to give an idea, this is what the plays look like. You won't have time to look at each play individually, but you can see that the balls move in all directions and there are multiple players on the field. So we try to convey as much as possible of the variability in the baseball games. So first we compare accuracy. And we can see that HistoryTracker is 30% more accurate than the baseball annotation from scratch. This was really surprising for us because we originally thought that our annotation and the baseball annotation from scratch was going to be exactly the same. But then we started thinking about it, and this actually makes a little bit of sense. So if you look at the screens of the video footage, you're going to see that the baseball camera points at specific portions of the video. So essentially, the user is not going to see the entire field at all times. The user has to think about and estimate the positions of the other players. And therefore, this is going to introduce a lot of error in their annotations. If the user uses historical data to approximate these trajectories, then the results are going to be better. And this is what we see in our chart. Finally, we also have a time comparison of HistoryTracker with the baseline. And HistoryTracker is 26% faster. We already expected this, but this is great news because 26% is not a lot if you think about it. But if you think it at scale, then it makes a lot of difference. So one baseball game has approximately 67 batted balls. So if a person needs to annotate all those games, this person is going to save more than 1 hour. And that's a lot of effort that this person is saving. One Major League season has more than 2,000 games. So if you think about it, this person is going to save 3,000 hours in hand annotation. And that's a huge effort that they are saving. Finally, here we have some example annotations. So on the top, we have the ground truth of the trajectories that were annotated, and on the bottom you have the trajectories annotated using HistoryTracker. And you can see that the top trajectories and the bottom trajectories look very alike. So not only is the error computed very small, but also the overall trajectory look the same. So here are some conclusions. HistoryTracker is a system that starts annotation using historical tracking data. And we noticed that it produces high-quality data with lower user input. What's the advantage of that? Well, manual tracking is much cheaper than automated tracking. So if you think about it, Major League Baseball spent millions of dollars in their system that uses cameras and radars to track the player in ball position. However, with manual annotation, anyone can just drag and drop things on the screen and create tracking data that can be used for analysis. This is very useful for smaller teams and minor leagues because they don't have as much money as those major companies. So we can democratize tracking data and analytics for smaller teams. As future work, we have proposed HistoryTracker for baseball, but this can be applied to any other number of domains. Such, if you think about sports, then any other team sports such as basketball or soccer can take advantage of our method. And we just have to come up with questions that enable the quick retrieval of plays to enable users to quickly approximate what they want to annotate. But what we want to do is minimize the user effort by using previous data that we already acquired. Another thing that I want to point out is that even if you don't work with sports, you can think about, well, everybody needs labeled data, and everybody needs to make users label data. So can we think about ways to use previously collected data to make this process faster and effortless? So I encourage you to think about this. Everybody has lots of data collected. Everybody needs to collect more data. So let's try to make this work easier for our users. And with that, I thank you all for your attention, and I open for questions now.
Thank you, Jorge. Questions?
Thank you very much for this presentation. It was very interesting. Question. You mentioned in the last sentence exactly something that I was wondering about. You mentioned that you can use this kind of tool, HistoryTracker, for annotating other fields. For instance, gameplay or human-computer interaction in some way. But you also mentioned that you have 8,000 hours of data with zillions of coded events. What would be the minimum time needed to feed your database?
I see. We actually thought about this, and we're trying to transform this system into a product. But these 80,000 hours of plays that we have so far, we cannot use them because those are private. So we have to somehow create this data from scratch. And the idea is that using manual annotation from scratch, you can crowdsource it in Mechanical Turk or whichever system. And then, let's say, if you have 100 plays, this can be already used to approximate the next ones. And as when more users start using the tool, we're going to gather more data, and this is going to make the process faster and faster. So I hope this answers that.
Thank you.
More questions?
Hi, Cliff Lampe, University of Michigan. I appreciate the work. It's really cool combining kind of the spatial element plus the time series data. Have you considered applying it to non-entertainment activities? So the thing I was thinking of would be like logistics or the factory floor or things like that. Is there anything different about the context of work than you think about the context of play?
Yes. So one particularity of the baseball games is that they are very structured. So this list of events that I presented before, they clearly describe every single action and every single movement of players. I'm thinking that in an industrial setting, these movements are not going to be as structured as in a baseball game. So it's going to be a little bit more challenging to apply this system in this setting. But it's possible. So if you think about the questions that you can ask, for example, where are the employees situated, or what's the K closest employees to this person. And based on these questions, you can query the database and approximate those trajectories. So it involves a little bit more work, but I hope this is possible as well. Thanks.
We have time for one more question. We're not going to start the next one until 20 to 12, so better to have a question than to stand here silently. Anything else you want to say, Jorge?
Well, this is just my first Kai, so I'm really happy to be here. And yeah, thank you very much.
I have one simple question. Right. Errors. Is that something that the system is accounting for? And if it is that something that's typically annotated? I know some baseball, but I know errors happen, right? And if a ball is not caught or something happens, right, that has to be annotated. So is your system flexible to include those?
Go up to the podium and use the mic, please.
Yes, so these errors are included in the questionnaire. So the user is going to, the user never introduces new events to the system, but he uses historical data to give those events importance. So yes, it's possible.